Hi, today we're going to go over lesson 6.6 over trapezoids and kites. So first, let's define what a trapezoid is. Okay, so a trapezoid is a four-sided shape, a four-sided polygon, where opposite sides are parallel. So we call these opposite sides that are parallel the bases. So again, the parallel sides are called your bases. We have something called the base angles. So you have sets of base angles. So this up here along the top where this first base is, these together are considered one set of bases. So notice I have angle A and angle B. That is a set of base angles. For base number 2 at the bottom, you have another set of base angles, and you have angle 3 or angle C and angle D. Now we also have two sides over here that are non-parallel. Those are called your legs. They are non-parallel. Now don't assume your base is always on top, because I could rotate this picture something like this. And is the base still on top and on bottom? Of course not. The bases are the parallel sides, so the bases are now on the left and right. So again, just make sure you remember the bases are the parallel sides. Now next, if you have an isosceles trapezoid, isosceles means you have two equal sides. So now if you have an isosceles trapezoid, you have two, again, equal sides. You have two equal legs. So notice on this picture here, the marking, I have marked it congruent. This is the definition. A trapezoid is isosceles if and only if the legs are congruent. That is a biconditional statement, so you could read it frontwards or backwards. So if the legs of a trapezoid are equal, then you know it has to be an isosceles trapezoid. Now there's also another piece of information down here we need to draw in. It says if it's isosceles, the diagonals are congruent. And we're going to use this actually quite a bit. So this is what I mean by diagonal. And you might want to go ahead and draw this in. If I could draw straight, those two things, those two are equal. So AC is congruent to BD. They have the same measure. Now, notice in this picture, I have these circled. These two angles together are always going to equal 180 degrees. So it's a base angle from one at the top and it's a base angle from one at the bottom. Notice they are not a set of base angles. A and B are a set. C and D are a set. But we're not doing that. They're consecutive and they are not a set. So here's what I mean on this one. I add these two together and I add these two together and I know the sum, S-U-M, sum, has to be 180. So to get the answer, it's pretty simple. You just grab a calculator, 180, and you subtract the angle that you know to get 89. So that's how I got the 89. So the next one, I have 180, and I subtract away the angle that I know, 132, and I have 48. Okay, let's keep going. I know together these equal 180. I did my circles. The circles are a good thing to start doing. So you remember, how to do it. If one of them is 90, the other one has to be 90 because together they equal 180. So it looks like I didn't write this one in. So let me grab a calculator. Okay, so we're going to take the total, which is 180, and we're going to subtract 124. So 180 minus 124 is 56. So this angle is 56 degrees. As you can see, it's really not that difficult. You just have to figure out what two angles you're adding together. So find the parallel sides. These are the parallel sides. And then find the two that together equal 180. So again, how do I get the 127? 180 minus 53. Now this one's tricky. there was no information over here on the right side. So how did I get these two numbers? Now, did everyone notice that these were isosceles? Isosceles means two equal sides, which also means your base angles, the set, are the same. So if this angle down here was 53, that means its corresponding base angle would also be 53. And if I know this angle is 127, I know its corresponding angle is also 127. So that's a little tricky. Now this one, I have 108, but notice it is isosceles. These two together I know equal 180, so I can figure out the 72 just by taking 180 minusing the 108 to get 72. And we have sets of base angles. These two are both the same, so I knew it was 108. Since I already had the 72, I knew its corresponding angle was also 72. Okay, so let's move on. The mid segment, which of course mid means middle, the middle segment of a trapezoid connects the midpoints of the legs. So this segment in the middle is just the mid segment. That's the vocab word, and it connects the midpoints. So if I wanted you to tell me the length of it, it's simply the average. Notice I wrote that here. The length of the mid segment is the average of the two bases. So this is actually pretty easy. You guys know how to do averages. You add them up, then you divide by however many that you have. Well, we always have two bases, so that means we're always going to divide by 2. So let's add the top and bottom bases, add them up, divide by 2, and I get 10.5. Now, sometimes it gets a little bit more tricky because the variable isn't always in the middle. We're going to add the top and bottom together. So notice I have 8 plus x. Now, I always divide by 2. So notice I did that there. And it equals the middle segment, which is called the mid segment. Now, to solve this, what you're going to do is you're going to divide, or you're going to get rid of this 2. And the way you do that is you multiply both sides by 2. When you do that, the 2's cancel out. So you're left with 8 plus x equals 22. And the 22 is from 11 times 2. Now subtract the 8 over and you get a final answer of 14. Now, as you can see, each one's going to get a little bit more difficult. So some kids can try to figure these out on their own. They don't want to do the equation. Kids want to fight me every year on it. But if you get used to doing this equation, adding the top plus the bottom, dividing by 2, it will help you do every single problem, even crazy hard ones like this one. Guys, it's the same process. We're going to add the top and bottom base together, which I wrote right there. I always divide by 2 because there are two bases. And it equals the middle segment, which is called the mid segment. Now, just like we did before, you have to get rid of this division, which is this 2 down in the denominator. So I'm going to multiply by 2 and multiply by 2. Now, on the left side, those 2's are gone. So these are gone now. Now, on the right side, I have to distribute the 2. So 2 times 3x is 6x. 2 times negative 6 is negative 12. And I'm just going to clean this up. What's 25 and a negative 1? Well, that's 24. So you're going to just do your algebra now. Solve. Subtract 2x. And it looks like my answer got cut off, so I'm going to have to finish this again. So I moved the 12 over, so I got 36 equals 4x. So 36 divided by 4 is 9. So this used to say x equals 9. All right. There it is. Okay, so Next, we're going to talk about a kite. Now, here's the easiest way to think of a kite. Now, I know I drew a lot on this picture, so I'm just going to redraw one real fast. A kite always has two sets of equal sides, and they're always right next to each other. A lot of shapes, like opposite sides are equal, like a rectangle, but this one, they're right next to each other. And here's how you can think of it. Do you guys remember isosceles triangles? A triangle that has two equal sides? Well, this is technically two isosceles triangles that share a side in the middle. So like right here, this is triangle number 1. Notice it has two equal sides. Here's triangle number 2. It also has two equal sides, but they are not the same size triangles. So there's two different isosceles triangles that meet together. Okay, hope that's clear. Now, a kite has two pairs of adjacent and congruent sides. Okay, so properties of a kite. The diagonals are perpendicular. Okay, so that's important. Take a second and let's draw this in. Notice this is a diagonal and this is a diagonal, and I drew in the little right angle. So you need to fill that in. You have only one pair of opposite angles that are congruent. So again, we're talking about opposite angles. So what we're talking about, remember how this is a triangle and this is a triangle? These two angles are going to be the same no matter what because it's isosceles. And then these two are going to be the same no matter what because it's isosceles. So if you add the two together at I and you add the two together at E, they're going to be the same no matter what. So those are the two that are always equal. Those two. I mean, a lot of times you can look at K and T, those two, and tell that they're definitely not the same. So just remember there's only one set. It's usually the set that's closer together. That's one easy shortcut way you can think about it. Now, this says there's only one pair of vertex angles that is bisected. So the other set that we haven't talked about yet, so we're talking about up here at K and back here at T, they're bisected, which means they're cut in half. So go ahead and write in the information that they're cut in half. Now, we will have to apply a lot of this information. So let's try it, and I'll explain as I go. So on this one, I know this is a kite. I know these two little red marks mean that they're equal in measure. What did I just do? Here it goes. Okay, so to find my answer, it's a four-sided shape. So it's 360 degrees. If you forgot how I figured that out, there are four sides. I subtract 2 because that's the formula, and I times it by 180. So that's 360. So I know my total is 360, and I'm going to subtract away the two angles that are provided, the 29 and the 95, and I get 260 or 236. And since I know these two angles are both equal, I divide this by 2 to get 118. So my answer is 118. Let's try the next one. I know this total is 100 or 360. Again, we talked about that already right over here on the left. The total is 360. Now, you got to find and see if you know which angles are equal. I know the 118s are equal, so I'm going to go ahead and fill that in. And then I'm going to subtract away the 81, the 118, the 118, and get 43. Okay, on this next one, there's lots of things you have to kind of understand. Now, one of the rules is that the diagonals here form right angles. So angle 1 is 90. We know that. And so if it's 90 here, it's actually 90 all the way around. And I'll do it, but you guys don't need to do it. If I put it all the way around, it looks really weird. You normally, if one's 90, you just understand they're all 90 and you don't have to write them all in. Now, I went ahead and drew this one in just because I'm focusing in on this triangle on top at the right, this one right here. How do I find angle 2? Well, this yellow triangle is 180 degrees because triangles are always 180. And I showed my work down here. I took the 180, I subtracted away that right angle and the 27 degrees, and I'm left with 63 degrees. Now, angle 2 and angle 3 are both the same measurement. Okay, and why? Why are they the same measurement? Okay, let's go back. Do you guys remember this is the isosceles triangle? 2 equal sides mean you have 2 equal angles, so these 2 angles are both the same. So that's why they're both equal. So the answer is 63. Okay, so we're starting to make lots of work here. All right, so to the nearest tenth, find the side lengths of the kite. Okay, so those are your diagonals. But if you notice, those diagonals make triangles. And I have to look at it and figure out a few things. First of all, what sides were equal and what angles are equal. So remember, that's a triangle. This is a different triangle. You also know that this line right down the middle cuts it in half. So if this is a 5, you know on top it's also a 5. So I mark them as congruent. I know they're both 5. And now you can just do Pythagorean. Pythagorean never goes away. So let's look at this little red triangle here. How can I find AT? Well, I didn't know this yet, so that's gone. I know this side going up and down is 5. The 8 was provided. So let's look right over here. I took AT and I squared it. And the legs were 5 and 8. And I did Pythagorean. And I'll let you guys try that. I got 9.4. So that's how I found that measure. Now, remember, it's a isosceles triangle. So if this is 9.4, you know this side is 9.4. So we're going to do something very similar to the other side. So this is a little right triangle. We know that's a right angle. We know we have a 6 and we have an 8, or 6 and a 5. And so right down here, now I wrote MH, it would be the same thing as MA because they're both the same. I plugged in my sides were 6 squared and 5 squared. I did my Pythagorean theorem, and I get that both MA and MH are both 5.8. All right, so again, how do you do this? Where do you start? Well, I'm going to start this one with this triangle. Now, I know when they cross here in the middle, it makes a right angle, so I have a right triangle. My 8 is my hypotenuse. So notice 8's over here by itself. My leg is 6, and the side that goes up and down, I don't know. So I called it X. So I did my Pythagorean, and I get 5.3. So notice, make sure I labeled it as 5.3. And I know the other piece there is also 5.3 because K to T bisects the segment. Now you have enough information that you can start doing Pythagorean all the way around to get your answer. So notice over here for KE,